All right, let's talk about something huge. In today's massive data platforms, we're dealing with environments that can have thousands, even tens of thousands of servers and countless users all trying to work at the same time. So the really big question is, how on earth do you keep all of that data secure? Well, today, we're going to break down two of the absolute pillars of data security architecture, KMS and Kerberos. I want you to think of a big data cluster like a massive, bustling digital city. You've got thousands of citizens, which are your users, and all these different buildings, which are your services. Things like Hive, Spark, HDFS. Everyone's constantly moving around, trying to get work done. Now, in a city that busy, how do you make sure only the right people get into the right buildings? And, more importantly, how do you protect the really valuable stuff inside?
So here's our game plan. First, we're going to look at the core challenge of securing this digital city. Then we'll meet our two main guardians, Kerberos, who's like the bouncer checking everyone's ID, and KMS, who holds the keys to all the vaults. And finally, we'll see how they have to work together to create a truly secure system.
You see, in a huge distributed system like Hadoop, securing that city of yours really boils down to solving two fundamental problems. First, you need a rock-solid way to verify that every person and every service is exactly who they claim to be. And second, you have to protect the actual data sitting inside those services, making sure it's completely unreadable to anyone who shouldn't be seeing it.
And we have names for these two challenges, authentication and encryption. Authentication is basically your ID check. It answers the simple question, who are you? Encryption, on the other hand, is your data's personal safe. It makes sure that even if someone manages to snatch the data, it's just a bunch of useless gibberish without the right key. And to solve these, we bring in our two specialists, Kerberos for authentication and a key management system, or KMS, for encryption.
Okay, let's dive in. First up, we've got Kerberos. The best way to think about Kerberos is as the central government agency of your entire digital city. It has one job and one job only, to issue official, totally tamper-proof identification to every single user and service. This makes sure that nobody can just show up and pretend to be someone or something they're not.
So technically speaking, Kerberos is a network authentication protocol. It acts as a trusted third party for everyone in the system. And it uses this really clever system of encrypted tickets, they're like digital passports, to validate everyone's identity. This is what stops a bad actor from just waltzing in and claiming to be a legitimate user, or even worse, a critical service.
Now, at the very heart of this entire system is one single, incredibly critical component, the Key Distribution Center, or KDC for short. The KDC is the central authority. It's the main passport office for our city. It's the one responsible for checking everyone's credentials and then handing out those secure tickets that grant access to everything else in the cluster.
So, how does this digital passport system actually work in practice? It might sound complicated, but it's a really logical flow. Let's walk through exactly how a user gets their credentials checked to get into a service. Let's say the Hive data warehouse.
Okay, here's how it goes. First, you, the user, go to the KDC and prove who you are, usually with a password. You ask for a special ticket called a Ticket Granting Ticket, or TGT. Think of this TGT as your main building access card for the day. Once the KDC checks you out, it gives you this encrypted TGT. Great. Now with that building pass in hand, you can go back to the KDC and ask for a specific key card to a secure room, in this case, the Hive data warehouse. The KDC checks your main pass, the TGT, and says, yep, you're good, and issues a service ticket that's only valid for Hive. You then take that service ticket, show it to the Hive service, Hive checks it, and finally lets you in.
And just like that, boom, Kerberos has verified your identity. You're officially authenticated, you are inside the building, but the job's not quite done yet.
And here's the catch, right? Just because you have a valid ID and you're allowed inside the building, does that mean you can just walk up to any vault, crack it open, and see what's inside? Of course not. The most sensitive data is encrypted, locked away tight in digital safes.
This is exactly where our second guardian comes into play, the KMS, or Key Management System. If Kerberos is the tough bouncer at the front door checking IDs, then the KMS is the master locksmith who holds the keys to every single data vault in the entire city.
A KMS has one absolutely critical job. It securely generates, stores, and manages all the cryptographic keys that are used to lock and unlock your data. It's essentially a highly fortified centralized vault that keeps the keys completely separate from the data they protect, which, by the way, is a fundamental security best practice. You never store your keys in the same place as your locked up valuables. So, you might be wondering, how does the data platform actually talk to one of these external key vaults? Well, it uses a kind of universal language called KMIP, the Key Management Interoperability Protocol. Just think of it as a secure, standardized connector. It lets the data platform ask for keys from any enterprise-grade KMS, which is absolutely crucial for meeting those strict security and compliance rules.
The role of the KMS here is so important. It enables powerful features like transparent data encryption. What that means is data that's just sitting in HDFS is automatically encrypted, without you having to change a single line of code. And by managing keys outside the cluster, you get a single central place to control and audit everything, which is totally non-negotiable for any organization with serious compliance needs.
Okay, so here's the main takeaway. Neither Kerberos nor KMS is enough all by itself. Not even close. Real robust security comes from layering them together. Think about it. Without both, you have a massive security gap. Authentication without encryption means insiders can see everything, and encryption without authentication means you don't even know who's trying to open your vaults.
This table just breaks down their distinct jobs perfectly. Kerberos is all about authentication. It answers the question, who are you, using its KDC to hand out and check tickets. The KMS, on the other hand, is all about key management. It answers the question, what can you unlock, by carefully managing the keys in its own secure server. It really is that simple. One checks your ID, and the other gives you the key.
So to put it all together, when you try to access data, Kerberos is the first step. It validates who you are. Then, once your identity is confirmed, the system turns around and goes to the KMS to get the specific key needed to unlock the data you're actually authorized to see. You absolutely, positively need both of them working in perfect harmony. And that really brings us to the final and most important question. When you look at your own data platforms, do you have both of these guardians in place? Is every identity being strictly verified? And are your most valuable assets, your encryption keys, being managed securely and centrally? Because having both of these layers is the real foundation of a truly secure data architecture.